Combustion characteristics and engine performance. Welcome to this lecture on combustion characteristics and their impact on engine performance. Combustion lies at the heart of marine engine operation, as it determines how efficiently fuel is converted into energy and how reliably an engine delivers power. In this session, we will explore the science of combustion, the factors influence it, and the consequences of poor combustion on both performance and emissions. You will also learn how engineers monitor and optimize combustion to improve efficiency, reduce wear, and comply with modern environmental regulations. By the end, you will have a clear understanding of why combustion is not simply a chemical reaction, but a vital process that shapes our output, fuel consumption, and the overall health of marine engines. Lecture objectives. The objectives of this lecture are fourfold. First, we will explain the key combustion characteristics of marine fuels, such as ignition delay, set and number, combustion duration, calorific value, and atomization. Second, we will analyze how these characteristics directly influence power output, fuel efficiency, and the level of emissions produced. Third, we will evaluate the causes of poor combustion, identifying how issues like incomplete burning or poor atomization can lead to engine damage and high operating costs. Finally, we will explore best practices for optimizing combustion in marine engines, including correct fuel handling, maintenance, and monitoring systems. These objectives will provide both theoretical knowledge and practical strategies for improving engine performance. What is combustion? Combustion is the chemical process in which fuel reacts with an oxidizer, typically oxygen in the air, to release energy in the form of heat and light. In marine engines, this heat is converted into mechanical work, driving pistons and generating power for propulsion. Along with useful energy, combustion also produces exhaust gases such as carbon dioxide, water vapor, and, if incomplete, unwanted pollutants like soot and carbon monoxide. While the principle seems simple, the actual combustion process inside engines is highly complex. Timing, fuel properties, spray pattern, and cylinder conditions all determine how efficient the reaction will be. Good combustion means maximum energy release with minimal waste. Poor combustion reduces efficiency, increases costs, and causes harmful emissions. Understanding the fundamentals of combustion is essential for diagnosing performance issues and designing effective solutions in marine engineering. Key combustion characteristics of marine fuels. Several fuel characteristics play a major role in combustion. Ignition delay refers to the time between fuel injection and the start of combustion. A long delay can cause knocking, while the right delay ensures smoother operation. Set and number measures ignition quality in distillate fuels, with higher numbers meaning quick ignition and better engine response. Combustion duration is the length of time over which burning occurs. This impacts cylinder pressure and power generation. Calorific value represents the energy released per kilogram of fuel, with higher values producing more power. Finally, viscosity affects atomization, the way fuel is sprayed and broken into drops. Proper atomization is critical for complete combustion. Together, these characteristics determine efficiency, emissions, and mechanical stress. Understanding and managing them allows engineers to match the right fuel to engine requirements and optimize performance. Combustion stages in a marine engine. Combustion in a marine engine occurs in distinct stages. The process begins with the injection phase, where fuel is introduced into the combustion chamber. This is followed by the ignition delay period, a short gap before combustion actually starts. Next comes rapid combustion, also known as the premixed phase. Portion of the fuel-air mixture ignites quickly, creating a sharp rise in pressure. After this, controlled combustion, or the diffusion phase, takes place as the remaining fuel burns steadily. Finally, the afterburning stage ensures that leftover fuel particles are consumed. Each stage influences engine performance and emissions. Proper control of these phases prevents knocking, excessive pressure spikes, or unburned residues. Engineers monitor and adjust these processes to achieve smooth, efficient, and safe operation under different loads and conditions. Poor combustion effects on engine. Poor combustion has multiple negative effects on marine engines. Incomplete combustion often produces black smoke, unburned fuel, and carbon deposits inside the cylinders and exhaust system. A long ignition delay can lead to knocking, where sudden pressure spikes damage engine components. Poor atomization, caused by incorrect viscosity or faulty injectors, increases fuel consumption and reduces efficiency. Combustion instability creates uneven pressure distribution, placing mechanical stress on the engine and raising the risk of failure. These problems not only increase maintenance costs, but also cause higher emissions of pollutants, like soot and sulfur oxides. For marine engineers, identifying and correcting poor combustion is critical for protecting the engine, reducing costs, and complying with environmental regulations. Optimizing combustion for performance. Optimizing combustion ensures higher efficiency, lower emissions, and longer engine life. Engineers achieve this by maintaining proper fuel temperature and viscosity, ensuring that atomization is effective. Injector condition and spray pattern must be monitored regularly to prevent poor combustion. Cylinder trends provide valuable information for detecting early signs of instability or delay. Selecting the correct fuel type for the engine's specifications also plays a major role, as not all fuels behave the same. Finally, applying emission-compliant practices, such as scrubbers or fuel additives, helps meet environmental regulations while maintaining performance. By combining these practices, engineers ensure that combustion is complete, controlled, and efficient, delivering maximum power with minimum waste. Interactive quiz. Let's test your understanding with a short quiz. Question 1. What does a high Seton number indicate in marine fuels? The correct answer is rapid ignition, meaning the fuel burns more quickly and smoothly. Question 2. What is a consequence of incomplete combustion? The answer is increased carbon deposits and black smoke, which reduce efficiency and damage the engine. Question 3. Which of the following methods can improve combustion? The correct answer is controlling fuel viscosity, as this ensures proper atomization and spray quality. These questions highlight how fuel properties, combustion quality, and engine operation are closely linked, reinforcing the importance of monitoring and optimization. Practical demonstration. In this activity, we simulate monitoring of a cylinder pressure trace. By studying the pressure curve, engineers can identify late combustion patterns, which often indicate long ignition delay or poor fuel atomization. Once identified, corrective actions can be suggested. These may include adjusting fuel temperature to improve viscosity, checking injector condition, or recalibrating injection timing. Monitoring tools like cylinder pressure indicators and diagnostic software provide valuable feedback that allows engineers to act before serious issues arise. This hands-on approach bridges theory with practice, showing how real-time data helps maintain optimal combustion performance in marine engines. Additional resources. For deeper understanding, several key resources are recommended. MAN Energy Solutions provides excellent material on combustion processes in two-stroke engines, including diagrams and technical analyses. Chevron's Marine Technical Review offers insights into fuel behavior, performance trends, and troubleshooting methods. D&V Guide to Engine Performance Monitoring is another valuable reference, helping engineers use data effectively to improve combustion and efficiency. Exploring these resources will give you a broader and more detailed perspective, complementing the concepts discussed in this lecture and supporting your professional development as a marine engineer. Summary. Let's summarize the key points. Combustion is the chemical reaction that drives marine engines, and its quality determines performance, efficiency, and emissions. Important characteristics include ignition delay, Seton number, combustion duration, calorific value, and atomization. Poor combustion can cause knocking, black smoke, high fuel consumption, and mechanical stress. To optimize performance, engineers maintain proper fuel properties, ensure injector quality, and monitor cylinder pressure trends. Using suitable fuels and emission control practices further enhances efficiency and compliance. Mastering combustion management is essential for marine engineers for safe, reliable, and environmentally responsible engine operation. Closing. This concludes our lecture on combustion characteristics and their impact on engine performance. We have explored the fundamentals of combustion, the key fuel properties, the stages of burning, the consequences of poor combustion, and methods of optimization. Understanding these concepts equips marine engineers with the knowledge to improve efficiency, emissions, and ensure long-term reliability of engines. Combustion is not just a technical process, it is central to sustainable marine operations. Thank you for your attention, and I wish you success in applying these principles in your studies and professional career. With my best regards, Dr. Sama Tawfiq.